Hello. Yay. Why isn't the screen? There's always something, isn't there?
It's an adversary.
It's kind of like it. It's really this whole thing is
Be an arbitrary screen.
yeah. Okay, what are we doing here? Okay, guys. Comes on, holler. Right. That one was actually my mistake, not his. I wrote an email this big to the tech people about all the problems that I've had over the last couple days. All right, I've been working pretty hard because I had to get a test together for the next class and for you guys. And oh, I haven't told this fine Simon put together a list of all the solutions for those posted problems. He did it in the formal way, which I'm not quite, I prefer the game. So partly motivated by him, on the test, you have to think, well, do I make you do the formal game or the informal game? And I figured I would let people do whatever they wanted to do. So this is cut right out of the test. It says, I'm trying to not make it too long because they're a little hard. There's only 3 questions, and each one you have to either prove it's a tautology, i.e. it's true in every model, or prove that it's not. Why? Because there's some model in which it's not true, in which case you would find a model which it's not true, right? And what I'm saying is I recommend that you use the game because that's what I like. He recommends that you do the formal proof. So does George.
Actually, the informal.
All right, excellent. Now, I have, so the last couple of days, the extra work for me is that then I have to write up a solution in both directions. And so, I now have a fair bit of experience doing both. And personally, I'm biased because I like to. Why do I like doing it my way? It's because it's the way I've been doing my whole life, and it's the way I'm good at. I can just bang down the informal proof. I figure out what order the game goes, and bang, 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 I lay it down. Now, the formal proof is very similar, right? So you think after I've done the informal proof, I could just write it down. Yeah, but every line, now let me really warn you guys. If I were marking the informal proof, I can sort of read it and know what people are doing. But I've seen people's informal proofs, and well, the informal proofs, I know what they're doing, and I know where they're going wrong, and I know how to give part marks, right? The formal proofs, every pair of lines, every line needs to follow from the previous lines, right? In a real formal way. And if I were marking it, I've seen people hand this page of formal, and I'm like, Lord. So what do? I just line by line. I don't try to think. I do a George thing. And I don't try to understand what you're doing. And I just see line by line, does it follow from the previous? And when it doesn't, then I can say you were wrong, right? And it's more nuanced, because you got to think about what you need here so that it all fits together, right? So that's my opinion. Other people have different opinions, all right? Yeah, that's just kind of what I'm saying here, putting all the pieces together. But that being said, when you're doing the formal proof, especially, if you give a perfect formal proof and every line follows, then okay, you deserve full marks. But if I'm marking it and I don't know what you're doing, and I see it's not following, and I want to give you part marks, it would be nice to know what you were trying to do, right? And so a few extra words, extra intuition in there isn't going to hurt. All right. So I was also, thinking about formal proofs. I like this example of proof by cases. Remember it? You should definitely look over it, because I like it. It came from Simon. I haven't actually looked at Simon's proof of it. I'd be curious to see what he did. But on the left-hand side, it says every x has a potentially different y, right? On the right-hand side, there's one y, right? And so why should that ever be true? Well, in this case, it's true because the x and the y are separable, right? They're separate sort of things. And so in the informal proof, remember, we require 2 queries. If you play the game, you don't quite know what to do. So you throw in a banana when you don't know what to do, and you have to query the oracle twice, right? And then I wrote down a formal proof, which mirrored that. But this was the first proof I came up with. And I added a couple extra lines of text, all right? So here, what we're doing is we're removing the Forall, right? And when you remove a Forall, in my mind, you're saying it's true for all what? For all x. And so you can plug in whatever you want it to be true for, right? And what do we want to plug in there? Well, the adversary eventually is going to give us an x, and we want to plug in the adversary's x. But we don't have the adversary's x yet. So you could just say, what will the adversary call it, right? And I could have plugged in x sub adversary in there, right? I could plug in anything I want. But we only kind of make one query. Well, the Forall bit, we're only going to make one query to the oracle. And the way we're going to get away with it is both queries we're going to give the same name, right? X is free. It's a generic enough thing. So when we rip off the Forall x, we're plugging in just the free variable x, right? So it looks like you're just ripping off the Forall, but you should know you're sticking in the free variable x. And we're going to use that twice, right? Right, so that was the one little nuance there. And then what's the real goal here is, right, maybe this box should have come down to here. This y depends on the x, and we got to get rid of that, or else right, this is where the real fine tuning of the formal proof works, right? If you forget, here, let's do that. Let's remind you of if you're going to dare the formal proof, let's remind you of some of the rules, right? When you rip off an exist, well, then you have to say y sub exists, right? All the other subscripts in the informal proof, all the subscripts aren't needed. The only reason we put them in there is differentiate between a Forall x local variable first versus I have a concrete value, right? But you don't need to put them in, right? You don't need, in the formal proof, you don't need to put in the Forall. You leave it as a free variable. But for the exist, you need to put in the sub exists so that it's not a free variable, so that you can't replace it with a Forall, right? So that's why we're doing that. But look at what I'm also been adding here is a little note that I'm removing the exists here. But when I say, hey, there exists the y, I already have a free variable floating around, right? Now, if I removed this x, this free variable is not free. It's bound by the Forall, right? So then you wouldn't need it to add it, right? Going backwards, right? We add it without anything. But here it depends on the x, and so the y that we grab, the constant y depends on the x, right? Everybody get that? All right. So then, and then the problem is that we still have this dependency here, right? So the idea that Simon and I had out in the hall was, well, we got right. We have an or here. How do you use an or? Is you do it by cases, right? So here, cases for. Oh, see, I've been working on these, and there's sometimes mistakes. All right. So this isn't cases 4. This is cases 3. All right. It's this or here that are going to be our cases. All right. I have to remember to fix that typo. And then what are we trying to prove? What is our goal of proving by cases is to remove the dependency, right? And we're doing it by cases. So the alpha case is just easy, right? But now let's move down to the beta case. This is where we said in the hall, hey, we got this proof. And then when I laid in bed, I was thinking, no, look we got a beta by itself, but it's still dependent. And then I thought, well, this to me feels really kludgy, right? You know the word kludge, it's when you do something silly, right? You put in the exist, and then I hear I have a little note. Oh, I'm a little worried. Am I allowed to do this? And then I actually looked up the rules, right? And the rules are it's possible because the term here, yx, it has a free variable. That's not the problem. You only can't do it when it depends on an x that's already bound by a Forall, right? So it's a free variable, but I'm allowed to do it. And it's a term, so I'm allowed to replace it by a y, right? And then I can remove the y again. I can remove the exist again. And this time, the constant doesn't depend on x, right? Does that make sense? So in general, maybe you can whip down little example here. Okay, let me state, maybe if it's a short little proof, you can bang it down formally without thinking too much, right? But if thinking is required, which it is for all the test questions, right? I advise that you go informal. That's just my game. Anybody, any questions about this example? Or, oh, you don't know? The rules, I made them up, right? Right? So I'm not a reader. I've never read a logic book in my life. I've never taken a logic course in my life, I confess. But I just didn't like the George's method, right? And he and I, we literally spent months going back and forth arguing with each other, right? And all he would say is what you're doing is not the way the forefathers do it, and hence it's wrong, right? But later he admitted that there's these scrollum functions, and right? I mean, all I'm doing here, what are the rules I added, right? The rules I added is when you remove an exists, then tell me that it's a constant, so that, I mean, if you look at what was it, the 1019 book, right? What did it say? It said, remove the exist, put them back. Remove the for all, put them back. And then it had a little caveat. Oops, you can prove false things this way, right? And in that page, it said, be careful of, right? It said, when it's a constant versus when it's a free variable, right? It was saying it right there in the page. Now, I hadn't read that yet, but I knew there was a difference between a constant, right? If I say 0, that's a constant. If I say x, that's a real variable, right? Now, this thing is more like a 0, right? So I added that. I added this idea of dependencies, right? Why? Because I want every line of your proof. You can go into that one line of your proof and know what it means. You don't need this proofs that prove that proofs exist, right? The other thing I added, which we haven't really even talked about, is when you're an assumption, you have to make the free variable not free anymore locally. But we haven't even talked about that, so it's not going to come up. All right, everybody? Yeah, I made it up. And where did I look? I looked at my slides. All right? Yeah, but okay, let me tell you what I also did. So George's proof system, when you come up with a new proof system, you have to make two things are true. You have to make sure it's sound, and sound means you don't prove anything that's not true, right? And all the rules, really, it's pretty clear it's sound. If this is true, I know what this statement means. So if this statement is true, then this statement is true, right? You never produce non-true statements, right? Then the other condition is complete. What does complete mean? It means if it's true in every universe, you need to be able to prove it, right? Now, George's proof system, he had only a very few rules, right? Like 3 rules, right? And so if in my proof system, I can prove his rules, then I have his rules and I can do anything he can do, right? So that proves what I'm doing is sound and complete. And and I'm open for this debate, right? Any other questions? All right. So last night at about 10, I was thinking, oh dear, are they going to get that question? Right? You didn't do well in the last test. And why didn't you do well in the last test? Because you weren't really playing my game, right? I looked at them. People just weren't doing it. And I really believe that if you play the game, bang, 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 you can just write down the answer and be done the test in 20 minutes. That's, I really think that, look at the last test. How do people feel about it? If you had played the game, would you have gotten the answers? Right? So I was thinking, but do they really know the game? Can I review the game again? And it came to me like a vision, the silliest, here I call it silly example, likely spam. The only phone calls I get are spam. All right? So here's a silly example. All right? And I'm going to eventually move it maybe as our first example in the slides, but right now it's what we're doing. All right? So let's look at it. What do we do? What's the difference between the left-hand side and the right-hand side? Well, I changed the names of the variables. Why? So they don't get muddled up, right? And on the right-hand side, I put in some weird equations, right? And what's the significance of those equations? I made them up randomly, all right? And so then the question, first you have to understand it, right? You have to understand what is the nature of alpha, right? And if you haven't figured this out yet already, F's are functions that take objects and give you objects, right? Alphas take objects and give you true or false, right? So this alpha could be, hey, I take in 4 objects and I add, and here we're going to be working over the reals. I didn't say up there, but work. And let me tell you, there may be bugs in these slides because they were made, but literally I was making them on the subway before I got here. All right? All right, so we could say you gave me 4 objects and I'll say it's true if their sum is less than 100, right? You can write anything there you want, right? So here's the question. Here I'm writing really any weird equations I want, but I fixed on those ones. And here alpha can be any weird function. And the question is, are these two, we're proving left to right, but it's right to left as well. Are these two statements equivalent for every function alpha, right? How many people think yes? How many people think no? How many really have no idea? All right, that's a good answer. All right? It feels kind of hard to believe, right? So that's why we're going to prove it. And do you know how we're going to prove it? We're going to just follow Jeff's game without thinking. All right? More or less without thinking. And when actually I take it back, these proofs do require some really sophisticated thinking. And that part of the proof I give you in the hint, right? Let me give you a hint now. If you're not using my hint, you're doing it wrong. I don't give you vacuous hints, right? Really, the hints are there to help you. All right. All right, so yes, these are equivalent. And so now I'm saying, now I really do believe this. Do not let me do this example without you understanding it. All right? Because I claim that if you can do this example, you can do the test. All right? If you want to say what the study, memorize this example. All right? No, don't memorize it. Deeply in your soul, understand it. All right? Get it as your part of your religion. You know, you can say, what's my new religion? I believe in Jeff's game for proving logic. All right? And I say it's Jeff's game, but when I was a graduate student, there was this great postdoc who is, to this day, just orders of magnitude smarter than I am. And this is just the way he was doing it. And then when you when you read any math paper, this is the way they do it. Nobody does it formal proof method. Nobody. I can't even believe that our forefathers did it. Right? All right. So we have this alpha thing, and what do we get? Eventually we're going to get an oracle that's going to assure it's true for particular values A, B, C, and D, right? And what are we going to do? The prover needs to prove that alpha is true for particular values A, B, and C. No, A, B, and C. What are they? S, T, U, and V, right? Now, how do we get that one gives us the other? Is we make the objects the same, right? You hear what I'm saying? We just say, let's write it down here. This will give me this if 3s is really the same as A, and t plus 7 is really the same as B. Right? You hear what I'm saying? Right? If we make these equivalences, then these are equivalent. Right? All right. So let me just tell you, sometimes I'm going to go from S to A, but sometimes I'm going to go from A to S. So let's, oops, what? That should be divided by 3. Again, I said, I was working on these fast. Right? Everybody good? I inverted them. Right? Now, what is Jeff's hint? Right? I can tell you right now what Jeff's hint is. The ones in purple that is circled in purple are the ones we're actually going to use, because it depends on whether we're going this way or this way. And Jeff's hint might be, look at 3s. At some point, you're going to have to triple something, right? B minus 7. At some point, you're going to have to subtract off 7, right? U divided by 4. It's something you're going to have to divide by 4, and you're going to have to add a 4, right? So those are telling you the hard parts. You hear what I'm saying? And another hint is I don't do them randomly order. This is the order you're going to need them, right? So I'm going to tell you a bunch of things are fun. And if you don't use them in the order I give them to you, then you're doing it wrong. Right? Everybody get that? All right. So you need to know people's games, right? I'm thinking about take that set of slides. This set of slides is going to be so big. Thinking about cutting it in half. The first half was pre-Oracle, right? The first test was pre-Oracle. And this stuff is post-Oracle, all right? But what we're doing, this is the pre-Oracle game, right? If I want to prove this, right-hand side, what's the game? All right? So everybody, if you don't know this yet, you better learn it fast or you'll fail, right? So what's the game? The game is I need to prove it implies. So I assume the left-hand side, right? She's going to assure it to us. And then I have to prove the right-hand side, me as the prover, right? And then how do you prove it? You read it left to right, right? So when I see a Forall S, how do I prove a Forall S? My adversary gives me an arbitrary one, right? So if you were actually writing a math paper, you would say let S be arbitrary, right? I really don't think it would hurt anybody if you put in there given to me by some adversary, because it reminds people that this really is a worst case. It's not a random guy. It's not a best guy. It's really is the worst guy, right? All right, now how do you, now I know the S. And knowing S, I come up with it. What do I have to do? I have to construct T, right? And I construct T from the S, right? Everybody buy that? And then, knowing S and T, my adversary gives me an arbitrary U, right? And then, knowing S, T, and U, I have to construct a V, right? And then I have to prove that now I have all these objects, right? And with all these objects, I have to prove that the alpha is true, right? Everybody get this game? All right, so again, if you're not playing the game like this, you're going to get it wrong, right? Have you heard my hippie stories that when I started teaching, I used to say, everybody do it your way because we're all free, right? But I've been teaching since before you were born. And the people who know how to do these things do it my way. They're willing and they're able to do it my way. And the people who say, I don't understand your way, so I'm going to do it my way, except for once or twice per 50 years, they get it wrong, right? So do it my way. All right, so that was good. Now, the prover, the way you do the proof is you do the prover proof. You assume, you bring in the oracle, you assume the oracle, and then you do the prover proof, right? And you keep doing it until you get stuck. And when you get stuck is when you have to construct something that you don't know how to construct, right? And how do you then proceed is you get help from the oracle, right? So I added when I need it because we're only going to do these parts, each step we're only going to do when we need it, all right? So what are the steps? Well, at the very beginning, she assures us that it's true, right? And then if she's assuring us that it's true for all A, then I'm going to say, oh, yeah? You say it's true for all A. Is it true for Jeff, right? So what does she do? She's willing to take an A from anybody, right? She says it's true for all A. Anybody can give her an A, and she'll say, yes, it's true for that A, right? Now, once she has an A, right, this B depends on the A, right? So don't say she gives me a B, and she will not give you a B until you've given her an A, right? In fact, remember that funny proof where we had to call her twice? And the reason we had to call her twice is because I wanted the B, but I didn't have an A to give her. So I gave her a banana, which gave her, helped her with her sugar levels. And then she was willing to give me a B, right? But then I got an A that I cared about, and I gave her that A, right? Remember that? That's why I talked to her twice, right? Because I really am not willing to deviate from the game. Because if you deviate from the game, you're going to get it wrong, right? And that's what I fear about the formal proof. Unless you can get all those working pieces just to fit together right, it's just not going to be right. All right, so here, now she has the A, so she gives me a B, right? Again, I have to give her a C, and then she's willing to give me a D, right? That's the game. It's the only, you go up to the oracle on the mountain, and you say, oracle, here's an A. She gives me a B. I give her a C. She gives me a D. That's the oracle, right?
Professor,
All
I
right,
have a
and
question.
then she assures you that, okay, we've constructed these four objects and alpha is true for them, right? Everybody good?
Professor,
Excellent.
do you
All right, so let's put those back in because we're going to need them. And let's just, now I'm just going to blindly write the proof down without thinking. All right? Close off your brain. You have no brain cells other than you know the game. All right? So how do you prove an implies? She assures you of the left-hand side. You have to establish your oracle, right? You say, yeah, this is going to be my oracle. She's going to help me, right? But you don't start playing with her yet because you don't know, you don't need help yet, right? And then what do? We have to prove the right-hand side, right? So to prove the right-hand side, you go left to right. It says for all S. How do you do for all S? We get an arbitrary one, right? I guess I'm getting a little ahead of myself. I said don't use the oracle unless you need her, and I'm not doing that. All right. So I know I'm going to give her this guy, right? So she's willing to take a value, and so I'm going to give her a value A, right? Everybody see this so far? I've been given an S, and she wants an A. What A should I give her? Should I give her my S? No. What A do I give her? Right? I look up here at the relationships, right? And I'm given an S. I want to give her an A. And I don't want her A to equal my S. I want her A to equal my 3S, right? I want this A to be this 3S. So what do? I look at this little equation, and I give her 3S. Right? Everybody get that? All right. Now, she's ready to give me a B. Right? So she gives me a B. Now, what am I supposed to do? I'm supposed to construct a T. Right? What T do I construct? Right? I want her to be to equal my T plus 7. So what should my T be? My T should be B minus 7, right? So I construct T to be B minus 7. Right? Everybody good? All right. Now we move along. It's a for all U, so I get it from the adversary. Right? And then we're going to go ahead and give it to the oracle. She's willing to take a C, right? But, right, I got a U. She wants a C. What do? Right? At this point, what was my hint? My hint was you're going to have to divide by 3. Oh, no. It was up here. My hint was you're going to have to multiply by 3. My hint was you're going to have to subtract 7, right? So we multiplied by 3. We subtracted 7, right? Oh, actually, I realized something that I was thinking wasn't right when I said it, but it came out of my mouth anyway. Remember I said the hard parts are when I have to construct something? Yeah, here's a hard part I have to construct. But an equally hard part is when I have to give something, right? I have to decide what to give. Right? So that can be a hard part too. All right? So my hint was multiply by 3. My hint was subtract 7. What's my next hint? Divide something by 4. Right? Right? I got to give her a C. I'm going to give her U over 4. Why? So that C equals U over 4. Right? All right, now she's going to give me a D, right? And what do I have to do? We're just reading left to right. I have to construct a V. How do I construct a V? Right? It says right here, the hint was add 4. So I construct it to add 4. Right? And now she assures me that that's true. And then I say, hey, you have a bunch of objects for which alpha is true. And my alpha has the same objects, so it's also true. Right? People get that? And that's the proof. Right? Does that make sense? Now, when I was typing in these equations here, I must admit at one point, instead of saying t plus 7, I was tempted to say 1 over t. Should I have done that? Nah, because then you got zeros you got to worry about, right? I was thinking about saying t squared, but then you got square root of t to worry about, right? Why does this work? This works because these are bijections, right? Everything over here has a thing over here, and everything here has a thing over here. So really, what we've proved is that you give me an A, I can give you a 3S. You give me a 3S, I can give you an A under the reals, right? That's what it's really saying, right? Everybody buy this? All right. Any questions about the game? Can you do the game? Do you understand the game? Are you going to get perfect? Yes. Really, you can get perfect. All right? All right, now let's do the formal proof. And I really was typing this as the subway arrived. So count on there being typos. All right? What do we want to do? We want to prove left side to right side. How do you do that? You do deduction, right? We assume the left side, we prove the right side, right? And then you start removing things, all right? So here, and I'm going to do just, I try to think, is there a way to balance, go back and forth to make this more understandable? And I said, well, that's not the way formal people do. Formal people write from the top to the bottom, all right? So I got a Forall A. What do? You rip off the Forall A, right? But you didn't just rip it off and plug in A. You knew where I was going, right? And you said, well, it's true for all A, so it's true for 3S, right? And then we rip off the exists, right? And when you rip, there exists a B, so that B is some constant, right? But don't forget that the B depends on the S, right? You could, in fact, sometimes in my formal proofs, I say B depends on S, and sometimes I say B depends on 3S, right? Depending on my mood. But either way would be fine, right? Does that make sense? All right, so we ripped off the exist B and replaced it with a B that depends on S, right? And then we rip off the Forall. And when we're ripping off the Forall, instead of Forall C, we can plug in what we want, and we know we need a 4U down here, right? And then we rip off the exists. And now this D that exists, it depends on all 3 variables beforehand, right? There is a D, but it depends on S and on U, right? People good? All right, so now we have our oracle statement for her values, right? And you know what I like about line 6 is because I can go backwards just as well, right? I know what line 6 means, right? Just because I make things up doesn't mean I'm wrong, right? All right, so now we still have these B's and these relationships, right? So I'm gonna define this B, right? We wanna get rid of this B, and we're gonna replace it with a T plus 7, right? And since the B depends on S, the T has to depend on S, right? And I must admit, when I wrote this line down, sometimes I wrote it as T equals B minus 7, and I switched a couple of times to see what do we want there, right? And the reason I wrote it this way is so that we can plug it right in, right? So now all I did is I took these equations and I plugged in for this value, right? Everybody follow that, right? And now this is looking like this, right? So I am sort of just, really this proof in some ways is pretty easy. You rip off the things and you do it to make it match the bottom. And then you do some manipulating in the middle while everything's ripped off, and then you put it back, right? In fact, why do we rip off things so that we have, remember the first part of the course was and, ors, nots, and implies in purple table. It had no foralls and exists, right? So what we do is we rip off the foralls and exists. Now we have and, ors, and nots. We do purple table, and then you put them back on again, right? Now, that's pretty much the way we're doing it. There's some more complicated things where you have to rip a little, do a little purple table, rip a little more, right? I mean, it can be worse, but this one is simply take them off, do purple table, put them back on, right? And so now we can just add them back on, right? Here, I guess the V here, right? I have this whole long complicated thing for V, but it's the VSU that exists, right? So we can replace it with just the V, right? They're saying there exists some V that's going to be this value, right? And then we add the Forall, then we add the exist, then we add the Forall, and then we're happy, right? Everybody get that? Oh, this is, whenever I start a new slide, I go to an old slide that I cut and paste from. So this is what I was cutting and pasting from. But I was going to add here this statement here, right? I find the formal proof less intuitive because you kind of have to know where you're going, right? And so I was gonna put this here, right? I find this stage here. Why did I remove the 3s? It's because I kind of knew where I was going, right? Everybody good? And that's it for those. Any questions about the games? Yeah. All right, so what was what was the question? What was the last sentence? Good question. So let's do informal and formal separate, right? And in the informal, I'm not writing these little functions, right? And instead, that comes from the order of the game, right? In the order of the game, the reason the B depends on the A is because I give her an A before she gives me a B, right? So the ordering the game makes the B depend on the A. While here, there's no game, so I write it in like this, right? Here I make the B here, not on the oh yeah, here the reason it depends, here it's already turned into an S, right? So it's depending on the S. Now your question is, does the C depend on the B, right? Well, in the informal game, the adversary is giving me the worst case C, right? And the adversary does it after knowing A and B, right? So you can kind of say that C does depend on the B. If I'd given a different B, then the adversary would have given a different C, right? But the reason we don't have to write it here is because it's worst case. And we can assume, what does worst case mean? Is that the adversary not only does it know what you've done so far in the game, but it knows your whole strategy, right? It knows everything about you. It knows where you live. It knows who your mother is, right? So in that sense, she's giving you the worst case C. So when I say remove, let's see, we're removing a Forall. Well, oh, no, down. Yeah, it's about here. Here, when we're removing the exist, it's the oracle's giving it to me, right? And so I want to remember that it's a constant. I guess this is the difference, right? Here, B is a constant. It's some specific value that depends on the S that the A and the S that I've given her, right? Well, the C is really something I'm giving her, right? So where did I get this C? I got it from my adversary, but we're not talking about that part right now. We're talking about the fact that we know this, and I get to give her a C, and I get to give her any C I want. And so in fact, you asked, does the C depend on the previous things? And here it, right here it's whatever I want to give her, right? So here I'm removing the A, and what is it dependent on? Well, it's dependent. This A is dependent on this S way over here, right? Because it's the S that the adversary gave to the player, right? And then here I'm giving her a C, right? And what C I'm giving her? I'm giving her U over 4. And that could have been dependent. That's dependent on this U. And I could have had it be dependent on these previous things, right? Did I answer your question? I think it's confusing, right? So how about my answer is yes, it sounds confusing. And let me try to answer it again. One answer, what the answer George would give is memorize the rules of formal proof, and those are the rules, and you just have to understand them. You don't have to understand them, but what are the rules? There are rules are when you're ripping off a Forall A, you can plug in anything you want, right? When I'm ripping off this Forall C, I'm plugging in anything I want, and it can depend. It can be any string of characters you want, right? In fact, let me tell you something else that George already says, right? There's no intuition, there's no meaning. It's only symbol manipulation, right? What am I plugging in here? When I plug in, am I plugging in U divided by 4 because U somewhere else? No, I'm plugging in a string of characters. The string of characters is U divided by 4. And I can plug any sequence of characters that I want. And then you have to get the character matching. It's about stick in arbitrary characters so that the characters match up in your rules, right? Does that make sense? right? So when you're ripping off of Forall, put in any characters you want. When you're ripping off an exists, you have to tell me that it's a constant and what it depends on. Those are the rules, right? And all right, so you see I'm not as comfortable with this proof, right? Everybody good? Yeah.
Strategy with this, the general thing when it's like for all A, there's just a B. It's like I give the oracle an A, she gives a B. When it's just an assurance by the oracle that starts with an exists, and that's just basically saying she just gives a B. Like say you have a standard.
Yeah, she just gives it.
There's just a B such as
Right.
alpha.
Right. Right.
And then you just start off there.
Yeah. So she, if you look at what she does, it needs to play her game in order. And when you look at what the prover does, it needs to be the game in order. And how you merge them together becomes an aesthetic issue. All right? Now, the reason I tell you don't go to her until you need her is because when it comes to giving her things, you don't know what to give her until you know what to give her, right? But in this case, if she starts off by giving you something, take it. Start off by her giving it to you, right?
You could have a question that maybe the order is reversed, like there exists a B such that for all C, so that you don't start.
Yeah. If this proof started with an exist, then she would have started by giving me something. Absolutely. Right? Yeah?
So I've been, up till now, I've been sort of stubbornly holding on to the formals.
Yeah.
I want to try out doing the informal one.
Yeah.
So I want to just get some stuff clarified. When we are writing down the informal proof
Right.
on the test, should it look similar to how you got it on the slide there, or should it be look more like formal proof with the numbering and all of that? Because that's what I.
Formal proof? Oh, the informal proof. You certainly, I turn it into dialog boxes, right? And you're not going to have dialog boxes, and you're not going to have animations, right? You're going to have just a bunch of lines, right? So what I advise in some ways is a little bit of a merger between formal and informal, right? You might start off with, I'm doing a deduction, so I assume this and I need to prove this, right? So that part is formal, right? Or you could do it this text in order, right? Here's a proof that would be fine. I assure the left-hand side I'm an oracle, right? You could put little comments about who I am. Don't say I. You could say oracle, semicolon. I assume the left-hand side, right? Or you could say, let's set up an oracle that assumes the left-hand side, right? You say assume the left-hand side. All right. And then then it's useful to put in goals once in a while, right? My goal is to prove the right-hand side. Tells people where you're going, right? And then we're going bang, 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 right? Then we can say, I got to prove a Forall S, so let S be arbitrary, right? And you might want to number the lines. If you ever need to refer to a line, then give it a number, right? Right. So then, then you say, hey, let this arbitrary, and then I could say, I'm going to give this to the oracle, and she's going to say, hey, the oracle says I take it and I give you a B, right? You could write the proof down just like this. You know what I'm saying? It gives you a little, Sorry, world. We had a mishap. All right, so let me show you. Let's go back to this. All right. I added this extra sentence here. right? If you really want, you can give me a formal proof, and you can give me some sort of mix between the two, right? But either way, you really need to follow the steps, right? When you do an informal, when the prover's game needs to be in its order, the oracle's order needs to be in its order, right? And what in the formal proofs, every time you do a line, it better follow from the previous, right? And then I wrote in here, even for formal proofs, you might want to add a few lines of explanation about what's going on, right? Once in a while, if you say, hey, what do I need to do now, right? So for example, if it's for all x, I can say, right, I can say let x be arbitrary. Hey, my sub-goal, what's my goal now? My goal now is to prove alpha of this adversaries guy, right? Put in sub-goals once in a while, and it'll make it even easier to follow what's going on, right? Now, why do you put in these extra hints, these extra statements about where you're going? I claim if you do it right, the marker will just, I'll tell you, when I mark, I get gestalt. I look at the page as a whole and just bang. If it's right, I know it's right. And I barely read it. I can just tell that it's right? It's when it's wrong that I got to figure out what are you doing and how many marks do I give you, right? That's where these extra lines help to tell me where you're going so I can follow you, right? And in my solution set, I put in these extra lines, right? Why? So that if you're reading my solution, you know where I'm going. So actually, I wrote up so many solutions for this test. I have, for one of them, I have two informal proofs, one which is just bang, 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 and one which adds discussion, right? And then in one of them, I have two formal proofs, one which follows the game and one which does something weird, right? So there are different ways of doing it. And then here's another thing I'm adding. Make your answer as easy to mark as possible, all right? i.e., it should be clear how to just read it, right? A correct but hard proof, a correct proof but hard to read, still might not get full marks. I'm putting that threat on you, right? And I'll tell you, that's what I'm saying is I hate marking. And if I look at your proof and bang, I know it's right, not only will I give you 100%, if I've marked half the class and gotten garbage so far, and yours is beautiful, I sometimes give 110%, right? I just like, thank you, right? But if I spent, in some ways, I'm willing to say that the mark I give you when I mark is directly correlated with how long it takes me to read it, right? If I have to figure out what you're doing and it takes me a long time, your mark goes down, right? It's evil but true, right? Right? It's transparent. It's transparent. And you think that's not fair, but it's fair because why did it take me so long to read it? Is because it was so wrong, right? Now, some of you have really bad handwriting and you have really light handwriting, and so it takes me a long time because of that. And I do my best not to take marks off for that, but it does make me grumpy, and you don't want a grumpy marker, right? Everybody good?